Daily space marvels, the cosmos inside, exploring the stars from morning to night.
Hey there, space enthusiasts! Have you ever wondered just how big the universe really is? Today, we're embarking on a mind-bending journey to explore the scale of the observable universe and what might lie beyond our cosmic horizon. From the tiny planet we call home to the vast expanse of galaxies and everything in between, we'll break it all down in a way that's fun and easy to understand. So, buckle up and don't forget to like this video, activate notifications, and subscribe to Daily Space Marvels for more amazing space facts. Let's start with our own cosmic backyard, the solar system. Our solar system consists of the Sun, 8 planets, their moons, and a bunch of other celestial objects like asteroids and comets. The distance from the Sun to the farthest planet, Neptune, is about 4.5 billion kilometers. To put this into perspective, if you could drive from the Sun to Neptune at a constant speed of 100 kilometers per hour, it would take over 5,000 years to get there. But even at this scale, our solar system is just a tiny dot in the vastness of space. Beyond Neptune lies the Kuiper Belt and the scattered disk, regions filled with icy bodies and dwarf planets like Pluto and Eris. The Kuiper Belt alone stretches from about 30 to 55 astronomical units from the Sun. Beyond that, there's the hypothetical Oort cloud, which could extend up to 100,000 astronomical units, marking the boundary between our solar system and interstellar space. Beyond our solar system lies the vastness of interstellar space. The nearest star to us, Proxima Centauri, is about 4.25 light years away. A light year is the distance light travels in 1 year, which is roughly 9.5 trillion kilometers. So, Proxima Centauri is about 40 trillion kilometers from us. Even traveling at the speed of light, it would take over 4 years to get there. If we used our fastest spacecraft, it would take tens of thousands of years. The distances between stars are so immense that it's hard to fathom. For instance, our solar system would be a tiny speck in a vast ocean if placed in the Milky Way. Interstellar space is not empty but filled with a thin distribution of gas and dust, which makes up the interstellar medium. This medium plays a critical role in star formation and the dynamics of our galaxy. On the fringes of our solar system lies the Oort cloud, a vast spherical shell of icy objects that extends up to 100,000 astronomical units from the Sun. This distant region marks the boundary between our solar system and interstellar space. The Oort cloud is believed to be the source of long-period comets that occasionally visit the inner solar system. Beyond the Oort cloud, we enter interstellar space, a realm filled with tenuous gas and dust, cosmic rays, and the magnetic fields of our galaxy. This vast expanse between stars is where we find rogue planets, isolated stellar remnants, and the remnants of ancient supernova. Cosmic rays, high-energy particles traveling through space, originate from supernova and other energetic cosmic phenomena, constantly bombarding our solar system. Our solar system is part of the Milky Way galaxy, which contains about 100 billion stars. The Milky Way is a barred spiral galaxy that's about 100,000 light years across. If you could travel at the speed of light, it would take you 100,000 years to cross our galaxy from one end to the other. The Milky Way is just one of billions of galaxies in the observable universe. It's composed of several distinct regions: the central bulge, the disk where most of the stars, including our Sun, reside, and the outer halo. The Milky Way also hosts mysterious dark matter, which makes up most of its mass but is invisible and detectable only through its gravitational effects. Our galaxy's spiral arms are sites of active star formation, glowing brightly with young stars and nebulae. Within our galaxy, stars are organized into clusters, and clusters into larger structures. The Milky Way is part of a group of galaxies known as the Local Group, which contains around 54 galaxies, including our closest galactic neighbor, the Andromeda Galaxy. Andromeda is about 2.5 million light-years away from us. The Local Group spans roughly 10 million light-years and is part of an even larger structure called the Local Sheet, a region of space containing several galaxy groups lying on a flat plane. The Local Group also includes smaller galaxies like the Magellanic Clouds, dwarf galaxies orbiting the Milky Way. The interaction between these galaxies leads to tidal forces, triggering bursts of star formation and influencing their shapes. Beyond the Local Group, we find the Virgo supercluster, which is a collection of galaxy groups and clusters. The Virgo supercluster spans about 110 million light-years. It's home to thousands of galaxies, including the Local Group. The supercluster is centered around the Virgo cluster, a massive cluster of galaxies about 65 million light-years away from us. The Virgo supercluster is part of an even larger structure called the Laniakea supercluster, which contains about 100,000 galaxies spread over 520 million light-years. This supercluster is held together by gravity and is moving towards the Great Attractor, a mysterious region of space with an enormous gravitational pull. The Great Attractor affects the motion of galaxies over hundreds of millions of light-years, illustrating the immense scale of cosmic structures. Zooming out even further, we see that galaxies and clusters form a vast cosmic web. This web-like structure is composed of filaments of galaxies and dark matter, separated by enormous voids. The filaments intersect at dense regions called nodes, where galaxy clusters are found. The cosmic web spans the entire observable universe, illustrating the large-scale structure of the cosmos. The intricate patterns of the cosmic web were shaped by the gravitational pull of dark matter and the expansion of the universe. These filaments are like the scaffolding of the universe, with galaxies forming along their length. The voids, vast empty spaces, give the universe its web-like appearance and contribute to its overall structure. Now, let's move out even further. The observable universe is the part of the universe we can see or detect. It's estimated to be about 93 billion light-years in diameter. This means that the light from the most distant objects we can see has traveled 13.8 billion years to reach us. Beyond the observable universe there may be more, but we can't see it because the light hasn't had enough time to reach us. The observable universe contains about 2 trillion galaxies, each with billions of stars and countless planets. Each galaxy is like an island in the cosmic ocean, with vast distances separating them. The distribution of these galaxies is not uniform but shows patterns and structures, revealing the dynamic history of the universe's evolution. What lies beyond the observable universe is still a mystery. Some theories suggest there could be an infinite number of other universes, each with its own set of physical laws and constants. This idea is known as the multiverse theory. While it's purely speculative at this point, it opens up a realm of possibilities that truly boggles the mind. Other theories propose that the universe might be finite but unbounded, meaning you could theoretically travel in one direction and eventually end up where you started, much like how traveling around the Earth would bring you back to your starting point. The concept of a finite yet unbounded universe challenges our understanding of space and time, suggesting a universe that curves back on itself. The concept of an infinite universe is mind-bending. If the universe is infinite, it means there are infinite possibilities, including the existence of parallel universes where every possible outcome of every event is realized. This means there could be another version of you watching this video right now in a parallel universe. While this sounds like science fiction, it's a fascinating topic that scientists continue to explore. Some researchers even suggest that black holes might be portals to other universes, adding another layer to the complexity of the cosmos. These theories, though speculative, push the boundaries of our understanding and drive the quest for knowledge in cosmology. So just how big is the universe? From our tiny solar system to the edge of the observable universe, the scale is almost incomprehensible. It's a humbling reminder of just how small we are in the grand scheme of things. Thanks for joining us on this cosmic journey. Don't forget to like this video, activate notifications, and subscribe to Daily Space Marvels for more amazing space facts. Until next time, keep marveling at the wonders of the universe.